Good morning, everyone. I'm Satish here from Pragnan AI. So this is the second session of 4 sessions project every Sunday. So the first session we covered what is segmentation, and we developed a model using SAM, segment any model, which is from Facebook research. So today we will be discussing about object detection, which is part of computer vision. So we already know what is computer vision, what is deep learning, and what is object detection. All those things we discussed in the first class, brief about like ANN, DNN, CNN, and all those things we discussed. So today we will only focus on object detection and what kind of tools are there to build object detection models. And also, like, we will be discussing 2 tools, very well-known tools, and also we'll be building a very well-known object detection models. So which is a state of art, means like which is sought after in the market, and object detection is heavily used in the market. Currently, you may be seeing so many applications using object detection. Okay, so let us start with what is object detection. So if you see this diagram, so what is that I'm trying to do? Now, 2 things are there. One, I'm trying to identify the object. Here the object is animals. So there is a cat, there is a dog, there is a dog, there is a cat. So one is identifying the object, that is animal here. And the second one is actually like I'm trying to put a this cover, what is called this bounding box. This is called bounding box. And on top of that, the name of that object. So bounding box is there. So bounding box is of any shape. So if you see here, actually bounding box covers the object. So maybe some extra, some here and there, but the bounding box is so that like the object is totally covered. So there is one is the identifying the object, and then notifying that object by creating a bounding box and then labeling it actually. So this is what is called object detection. So this is what is called object detection. So another example, if you see here, actually, like this is another example where I'm trying to do object detection. So this is a car is detected, and then a bounding box on that, and then the car. So apart from that, like if you see here, actually 0.97, what is that actually? 0.97 is actually 97% confidence level. Means like I am 97% confidence that this object is car. So the next one is a person. So 91%. And the next one is, if you see here, actually the handbag. And then if you see here, actually bicycle. So if you see like the person, bicycle, that, this, it's like, so all these, the intention here is actually identify car, person, bag, whatever that handbag, and bicycle, all those things. So what is this actually? These are the objects which we wanted to recognize. You can decide anything. So you can decide what object you wanted to recognize. And apart from that, like after detecting object, then the bounding box, and then the percentage confidence. This is what the model has predicted, model has detected, and what is the confidence level of the model finding it, and then bounding box actually. So it is showing. So from this image, I am trying to find out multiple objects. So I'm able to find out the multiple objects, and I'm trying to. The next one is actually, if you see actually, this is another example. So it is a manufacturing plant. So I'm trying to find out object. What is the object I'm trying to find out? There's one person, second person, third person, fourth person. So I'm trying to find out how many persons are there, how many people are there in this manufacturing plant. So I'm identifying. So for example, manufacturing plant should supposed to have 50 people. So this object detection keep on changing, like every time how many people are there. So these kind of camera-based object detections are installed in the manufacturing plant. So just instead of saying that like how many people are there or not, counting whether they are doing or not, actually everything can be done using the object detections. Like it can detect. So any moment I can count actually how many people are there in my manufacturing plant, or how many people are there in my class, how many people are there in my auditorium. So object detection will detect different kind of objects. So whatever you wanted to detect, actually, you can detect the object and then you can try to count them actually. This is one example of object detection. So it is in the manufacturing plant. So this is another example of object detections. It is an airport. So from airport, I'm trying to find out how many planes are there. If you see actually, my object detection is detecting planes. So this is one plane, two plane, three, four. So many planes. How many planes are there? I'm trying to detect. I'm trying to detect the objects. What is objects here? Objects here is a plane. So I'm trying to detect it. So fine. So this is another object detection example. So if you see here, actually, I'm trying to detect how many cars are there. So I'm detecting car. This is on a highway. So I'm trying to detect. So for example, if you want to see that, like, what is the strength or what number of vehicles they are moving on this vehicle, and I wanted to check actually. Like also I can check actually like how many cars, how many trucks, how many bicycles, sorry, two-wheelers, all those things. Like a lot of things. Like so nowadays, like this camera, I wanted to track it actually on highway, how many vehicles are moving around. They can use the object detections like car, truck, bikes, etc. So and also they can count like so per minute how many vehicles are moving around, or like from 1 hour how many vehicles are. It's like first object detection will detect actually. So keep detecting things. So the object detection is used there actually. So this is another example of object detection. I hope you understood what is object detection, correct? So here the objects are car, truck, bikes. So in this case, objects are aeroplane. So in this case, objects are persons. In this case, multiple kind of objects I'm trying to identify: car, person, handbag, and all those things. So it is, and here like animals. So depending on what you wanted to identify, so object detection will try to detect those objects. Objects can be a real thing or animal or person or anything. So I just in an abstract way we say it is an object. So whatever it may be. So we will be trying to detect the object. So what is the difference between the classification and object detection? So in classification, when you give an image, I will be classifying this image as one type. So here in this case, actually, I'm trying to define this as a cat. If I give an image and it will say this is a cat. So in that classification, I am trying to find out whether my class exists or not. Class means like I'm trying to classify dog and cat. So means like whether this image consists of cat or a dog. So if it is a cat, then I will classify this image as a cat. If it consists of a dog, then I will classify this as a dog. That is called classification. Object detection, when you say that, like in that image, how many objects which I wanted to identify are present, and then do the bounding box and then label them. That is called object detection. So classification and object detections. Any questions here? Okay. So object detections plus versus image segmentation. So image segmentation we discussed the last class. What is image segmentation? What is semantic subject segmentation? We discussed what is instance image segmentation. So object detection, when you say actually object detection, it is semantic segmentation when you say that I'm trying to find out like horse is one type and then grass is one type and then other things. So semantic segmentation will identify different kind of things with one different colors. So when we say object detection, apart from that doing that, also it will try to find out like so how many objects are there in that. Okay, I did for semantic segmentation, but plus I wanted to find out how many objects, how many horses are there. So one horse, one color, one horse, another color, one horse, another color. So this is how the semantic segmentation does actually. So object detection is something similar to some semantic segmentation plus something extra. What is that something extra is actually it will try to do something called a bounding box and then it labels actually. So it is as if you can say that like it is a semantic segmentation with the bounding box. So object detection plus semantics plus semantic segmentation is instance segmentation. The another way of saying actually object detection plus semantic segmentation is a instance segmentation. Instance means like here I'm not giving the name of I'm not putting the bounding box. So within this there is one horse, so I'm trying to create one instance. Within this there is another horse, then I'm trying to create another instance. Within this there is another horse, then I'm trying to. So this is object detection plus semantic segmentation, also instance segmentation. Or we can say instance segmentation with the bounding box is object detection. So this is how we can differentiate. So understood the difference between object detection, semantic segmentation, instance segmentation. Any question? Any question? Okay. So now when we see what exactly the object detection, so object detection has two things. One is object recognition, and object recognition is like image classification. I'm trying to classify, and then object localization. So what is object localization? Actually, identifying the zone. Localization is like, so for this image, if I say in this image, I found some object and I'm trying to localize, means like which area, local area that object belongs to. That is called localization. Localization means like, so it is local to what? It is local to means like which area it belongs to, or which part of that it belongs to. So this is entire thing is mapped now in that, like which local, means like which part it belongs to. So that is first is object recognition. What kind of object is there? That is image classification. Then object localization. So then object detection, object segmentation. So this is how the whole process works. Most like it is a identifying. So let us discuss actually, like first I have detected the object. So there is a deer is there, then there is a cat is there. And then what I'm trying to do, so how I'm looking at actually first object detection as classification. So what I'm trying to do, so I'm trying to do bounding box, and in this box I'm trying to find out, is it a deer, it is a cat, is a deer in a cat. So and then I'll keep on moving. So there's a deer is a cat, a deer is a key, deer, cat are background, deer, cat are background, keep on moving. So for example, here the percentage is deer is there. Okay, next here something percentage deer is there. So I'm trying to find out which all the portion there is a deer is classified. So here I found something about deer, here I found something about deer, here I found something. It's like this window keep on moving and trying to find out whether this portion there is a deer. So this is how the object detection works. So is the deer is caught, then I'm keep on moving. So deer and caught, deer and cat, deer and cat. So I'm trying object. So from after that, actually what I'm trying to show. So here I have found a deer. So all those things, where area, which all the areas I found deers. So I'm trying to classify with the bounding box. Makes like this box or this box. I'm trying to say this box. It's like I'm trying to figure it out actually. What is the box size? First is like where exactly I am finding, and then after seeing that, like which box will capture the entire deer. So this is how the whole is like I'm trying to figure out the box. So the if you think about object detection, it will be two things. One is segmentation. So why it is doing segmentation? So I'm trying to find out which objects. Segmentation is like different objects with the different colors, correct? So I'm trying to figure out where exactly those objects are there, and then finding out the bounding box. So using the regression method. One is a segmentation method to find out a segment, like find out the object. Another is a regression method to find out the bounding box. So if you think about the object detection, it will be two things are running. One is segmentation is running, one is a regression is running. Regression means like numbers. So regression means like numbers. So bounding box is a numbers. What is a bounding box? Numbers means like, so if you see here image, so this image starts from here 0 row, 0 column, something. So pixel wise, if you see actually this is some pixels this side. Assume that like 1000 pixels here, and here assume that like 8000 pixels. So this is 1800 kind of a pixel. From here, like what is this actually? This is actually like 50 pixel, 50 pixel. This is 50 by 50, and this is actually 100. Assume that like this is 300 by 50, and this is what is that means like bounding box means like a numbers. So pixel wise numbers. This is one value, that is x value and y value here. X1 y1, x2 y2, x3 y3, x4 y4. So 4 values I need to find out. That is a regression method. So regression will find out a value, correct? So what is this value saying actually? From which pixel to which pixel belongs to deer. So that is how when we are trying to do object detection, there will be two things will be there. One is a segmentation, another is a regression. Regression will try to find out the bounding box, and segmentation trying to find out actually local contrast are like which pixels are similar in nature. So if you say that, for example, deer, all these pixels are belongs to deer. So this is how the segmentation will give this whole thing is one color. Segmentation will give this whole things in one color, and this is what we will be trying to. So it is something like you can say that like object detection does two things, two kind of activities. One is segmentation, one other is a regression. But like no need to say that like exactly that way. But in a high level, I can say that like there is a segmentation and there is a regression things are there. And what is other things? What is the other things what we can say actually? Multiple objects. So we need to find out multiple objects, multiple view, multiple pose, multiple resolution. So stationary object, moving object. So these are the things what we will be trying to figure it out actually. So is maybe different kind of objects. So multiple objects or multiple views. So multiple poses. So different poses actually. Multiple resolutions like high resolution, that is also we can figure it using object detection. Stationary objects or moving object, that is another kind of things we can do. So object tracking, when we say object tracking, means like vehicle moving actually, or like behavioral emotional analysis. So what is the emotion of that person? So is it sad or something? So we will do one project today on emotional analysis by single object or multiple objects, and crowd analysis. So these are some of the examples where the object detections will be used. Any questions so far? What is object detection in a nutshell? And what is that difference between, see, how it differs from classification, how it differs from segmentation, and what are the two activities in object detection. So based on that, any questions so far? Okay, so now why this object detection is very important. So what is the necessary of this object detection? Object detection is very fundamental problem of computer vision. So we keep on doing from a lot of years actually. So we, before deep learning also, we used to do object detections. So object detection is actually image processing problem statement actually. We used to do a lot more things. But more specific application of object detection actually pedestrian detection. Means like in the driverless car, so identifying whether the pedestrian means like the person is walking on the footpath. So detecting that pedestrian walking or either in the footpath or crossing road. So pedestrian detection. Animal detection. So animal detection is like different kind of animal detection. What kind of animals are there? Or something that like you may be seeing in the forest thing. So whether the animals are coming, the forest animals are coming in the village or not. So that kind of things, or even in the roads kind of things. Like so, that is another thing. Or like animal detections, like so for proper kind of what kind of animal detection. Vehicle detections, like what kind of vehicles are coming. People counting number of peoples. I said no, like face detection, identifying face and then identifying the expression of the person. Text detection, so on that any image where exactly text is there, like so symbols or something that like in the vehicle, if you see that signboards, so there is a text detection will be there. Pose detections, what kind of pose is there. Detecting number plates, so number, this is most oftenly like now AI cameras you are seeing on the most of the highways AI cameras trying to find out the vehicle plate recognition, number of vehicles detection, and any violations detections, and even the crowd analysis. So whether the crowd will go do some kind of a violence or not, fire detection, lot more applications are there. Even in the airport, like something that like X-ray, instead of X-ray, like object detections will be used, so that like it will identify any unwanted objects are there or not. So these are the things most oftenly we will discuss actually one by one applications. But because of these multiple applications, multiple places where we can use this object detection, so object detection becomes very prominent kind of application of the deep learning. And people if you want to aspire like an AI engineer, So object detection, building some object detection models is essential actually. And that is the reason we are covering this actually. Like, so what are the things we are covering? It is important kind of a concepts. Like it is not like a simple kind of a concept, but like which is very important kind of a concepts. So object detection, like, so last time we discussed about the segmentation. So we are discussing today is the object detections. Okay. So this object detection is not the new things I said, no. So initially image processing techniques were there. So image processing, we used to do a lot of image processing kind of analysis. So technical image processing using, we used to do the traditional methods, and OpenCV is the one we used to use. We'll discuss, like some students we covered OpenCV, and annotation kind of images we have discussed. We'll discuss that later on. And most of the thing today, what we will be doing object detection is using deep learning methods. So using deep learning methods, and in deep learning methods, there is supervised, unsupervised learning. That what is supervised learning, what is unsupervised learning, we discuss actually. The supervised machine learning are like deep learning. Supervised is actually mechanism. With it can be machine learning or it can be deep learning. Supervised means like with the label. Label means like output. So input plus output. The unsupervised means like there is no output, like it will be automatically trying to find out. So deep learning object detection, there will be supervised, there is unsupervised methods also. It is not that like everything it is a supervised. So supervised method means like, for example, in this case, I have said actually like I need to find out deer, I need to find out object cat, I need to find out dog. Then it will try to find out deer, cat, and dog. That is, so that like means like I will be giving some labels, identifying the where is the deer, where is the cat, where is the dog, and then I will be training the model. So that is called supervised deep learning method. Unsupervised means like, so I'm just I'm giving that actually trained model or something that like I say that like you only figure it out actually. So it will try to figure out different kind of objects. That time it won't able to label, but it will try to able to figure out actually different kind of objects. So that is unsupervised. Like, so there is supervised also is there is unsupervised also there. And another thing is actually like very important concepts in the object detection is actually annotation. How should we do annotation? What is the data set is there? What kind of so the MS is a Microsoft Coco data set. Caltech is a university. They also have a data set. Kitty is another data set. Pascal, VOC, these are very well-known data sets actually. So labeled data sets, most of the people will be using. So you should be knowing. So you say that like, okay, so when we are doing the classification, when we did in classification in the class, we discussed about MNEST, we discussed about what is the other thing we discussed? MNEST dataset and CIFAR dataset and Fashion MNEST dataset. So these are the something that like a well-known kind of a datasets, like something that like we should be knowing. So if you say that like I don't know, I have done a deep learning classification model and I don't know what is MNEST dataset, then it understands that actually you've not done anything. So like that, similarly, like when we try to do object detection, so MS Coco is a well-known dataset, Caltech dataset is there, Kitty dataset is there, Pascal. This is most of the people will be, if I build a model, I will try to say how this model is performing in the Pascal. Why they have to do actually? Because already so many people has built a model and tested on the Pascal dataset and they have achieved 95%. Then when you define another model, then you need to check there. So that like you can check actually how much you are ahead of them actually. Because no, if you try to build some model in some specific things, then you don't know that like your model is far better. So benchmarking. So this kind of data sets is there, and I need to say build a model, and then I say that okay, my model perform this one, and then what are the other models? How much was the performance? So these are the very well-known models are there. So thing. So any questions so far? Object detection. What is object detection, and how this object detection will break? What is the sliding window, or like how these things works? All those things we discussed. Any questions so far? Okay. So this object detection has evolved over a period of time. I said no. So it is not that like a first one. If see, if I'm discussing about the deep learning approach. So image processing approach, it is from last 30 years, 40 years kind of things. So deep learning approach was started from 2013 onwards or 2014 onwards. Because deep learning started picking up from 2014 or 2015. Most of the time it is 2016 onwards actually. So not that far off actually, but like it is very recent one. But image processing was like 20 to 30 years. But like what we are discussing actually, generic update detection using the deep learning approach. So first one is 2014 RCNN. So CNN, we discussed what is CNN, convolution neural network. RCNN, R means like region. Region means like this bounding box, identifying the region where this class exists. So that is what like, so identifying the region where this class exists. So that is the reason the name is given RCNN. And there is something like a SPP. SPP layer is there. So that's what SPP net. Then FCR, fast RCN actually, and then faster RCNN. So these are the one set of region proposal based models actually. FRCN, FPN, mask RCN. So these are the well-known models actually. Like, so just like we discussed in the classification class, like VZZNet, ResNet, ImageNet, DenseNet, all those is the well-known classification models. So, and even in the segmentation, we discussed about UNet, VNet, and like SAM, all those are segmentation models, well-known segmentation models. So you should be, and something similar to that, like object detection models. Like, so these are the well-known object detection models based on reason proposal based. It means like identifying the reason. So that is all. And another set is actually regression and classification based. So approach what they have used. So based on that, actually there are multiple methods. Multi-box is one method, that is 2014. Attention network, it is 2015. GCNN 2016. So, and YOLO, this is what we will be doing. So we will be working on the YOLO today project. So YOLO first version 2016. Now what we have is actually YOLO 8 version 8. So YOLO also start evolving. So but started with 2016. And SSD, this is also another very, very well known. So YOLO 2, then DSSD, DSOAD, and a lot of things are all there, like every year. So 2001, so many are there in 2021, 22, 23. So what we will be discussing is something which is developed in 2023. So why, another reason like why the college won't be able to teach the prophet is actually because of these things. So things keep on evolving and your academics curriculum will be fixed 10 years back and 20 years back. Any college, if just any student just learning from the academics from the college won't be able to beat the people who are learning from something like a edutech institute like us, because they won't be able to learn the advanced things. Like, so now YOLO 8 is there. So in academic curriculum, it is not possible because it is launched in 2023 only. So, and also they won't be going that deeper into the things like subject detection itself is a very, very vast thing. So why we are saying this is, and why we need to track this actually, because we should be updated. So for example, generative or LLM or like Gen AI started like last 6 months, 1 year. So your academic curriculum was fixed in like something that like a 4 years or 5 years back. And all those people who are fixing this academics are just a theoretical person, but they are not worked any practical things. So they don't see the reason why I'm saying that, like why the students who educate from the top edutech institutes will be competing with the top colleges, like you will be competing. And even if I'm from NIT Surathkal, so I hardly see that like 1 or 2 kind of a models they will be developing in the entire 4 years, if they are not learning other than the academics. And if you are learning and if you are able to do all those things, what we say here, you will be far ahead of those NIT students also, because I know the curriculum, what they are learning. I'm directly interacting with them. So this is another reason where you will be having an edge over the other kind. Only thing is like how much you will be putting effort, how lazy you are is up to you. So, but in terms of the curriculum, in terms of the things, what we will teach, you will be far ahead of the other people, because see, most of the people even don't know that like how many object detections are there. So they don't know what is meant by reason proposal or like regression methods. Like that, lot of things are there. So just let us see a little bit like more about the evolution of the objects. So I said no before 2014. So it is all traditional methods. So like Velo Jono detector, this is 2001. Hog detector, this is pure image processing things, like Hog detector, that is 2006. DPM, that is 2008. These are the methods, historical, traditional image processing based methods, object detection methods. So from 2014 onwards, like so RCNN, Reason CNN, we get SPP net we discussed, correct? Fast RNN, faster RNN, mask RNN, pyramid network, GRNN actually. Then this is a two-stage method. What is the two-stage method? We'll discuss. And there is one-stage method. I said two path, no, one this side, one this side. So this is called two-stage, and this is one stage. YOLO, SSD, Retina Net, YOLO 3, YOLO 4, YOLO 5, YOLO 7. So now 2023, YOLO 8 is there. And what we'll be building model is using YOLO 8. And also, like if you see, actually, if you attend the whole college curriculum, and if you are enrolled, actually, like we will be giving all these workshops or models across all kind of techniques. It is not just like we will only teach the YOLO. So if you see here, like a lot of things what we are saying. So now deter is the transformer based. So MEDI detection is another, detection is another method, detector. This is cascade is another, cascade RCNN is another method. So models, YOLO 8 is one, mask RNN is one. So retina net is one, efficient deterrent is another one. Dectron is another one. So next is center net is another one. So next like faster RCNN. So like that, we will be developing at least important 6 to 8 object detections, either as part of assignment or either as part of your project. Because what we want know, so what all the useful kind of different kind of object detections you should be doing. And why we will be doing actually, because you should be far ahead of the other college, like even if it is a top college, because hardly they will be doing one or two. Like when you do all those things, like so YOLO is very important, SSD is important, retina net is one important, and one in RCNN or mask RCNN or fast RCN. It's like 4 to 5 if you have done, then you will be far ahead of the other people. So like that, like, and what is this one stage and what is this two stage object detection methods? Let us discuss what is one stage and what is the two-stage object detection method. So if you see that, like object detection in the deep learning approach, I will be classifying as a one stage and another is a two stage. So when I say two stage, like I'll be having two things. Like, so when we say that, like one is first is classification, another is finding out the bounding box. So if you want to see the in the one picture, like image, when you give feature map, and one stage actually bounding box regression and classification will be done in simultaneously. So first classify, and then after classifying where exactly that object is there, then automatically it will try to detect where exactly this bounding box is there. So detection. So this kind of approach is called one stage method. So two stage method means, like, so what we will be doing. So first is a box regression that runs separately. Object true or false. First, I am trying to find out object exists or not, and the box regression. I'm trying to figure out the box, and after figuring out the box, then I will be able to classify. It's like there are two steps are there. So reason proposal network and then classifier. So reason proposal network is one stage, classifier is another stage. So that there is a two stages are there. So there are some methods are two stage methods, some methods are one stage methods. So most advanced one, if you see, actually, like most people will prefer with the most of the things, the people will prefer with the one stage. Like after sometimes they stopped, researchers stopped doing innovations on this space actually. So all these, like all this what you are trying to see is actually somebody has done a PhD work on that. So somebody has designed RCNN, is like he has completed his PhD on RCNN. So all these are some PhD, some research work actually, most of that. Maybe some one person or maybe group of people. All are a deep research. And all these things are done from the top-notch colleges. So like MIT, Harvard, Berkeley, and all those Oxford, Cambridge, and all those things. Most of them, even Indian colleges also, but most of the times, like it is abroad colleges which will be done, and all these things, and what we will be studying. And there is a one stage and there is two stages. So one stage means like the first classification, it will be done like if you see here actually one stage, the classification, and then I'm trying to find out a bounding box on that. So two stage actually, like bounding box regression and then classifier, reason proposal network, and then classifier. So there will be two stages are there. And So most popular one will be one stage. And in that one stage, actually, most popular one will be YOLO. What is YOLO stand for? You only look once. Once you look, like, so how the person looks actually. When if I take a kid, actually, he will see the elephant one go and identify, correct? So only once you will see that, like, okay, once you see the picture, oh, then he'll, oh, elephant is there, cat is, tiger is also there. It's like in one, only once he will look and he will identify, correct? So something you only look once is a YOLO start from. YOLO. So only once, like the one stage. So the YOLO is very, very popular object detection architecture actually. So it is a single stage. And apart from that, like the corner net is there, center net is there, and so many others also there. So I mentioned here, no, so many others also there. Like so center net is there, data transport, lot of things are there. So we will be discussing today only the YOLO. So in YOLO also version 1, version 2, version 3, version 4, version today 2023 is actually version 8. Any questions so far? Any question so far? What is single stage? What is double stage? So in double stage, region proportional network is 1 and classifier is 1. So in single stage, detection head is 1. In first, it will detect the object and then figure out the bounding box. So in a single step. So there is no two outputs. So fine. Any question? Are you following? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So now this is one image. If I give this, what is this actually? This is CNN model. So what is the CNN, RNN we discussed, correct? So we can use CNN, we can use RNN, we can use a transformer, we can use autoencoder, anything. But how the model looks like, what is my design architecture, whether I can do using CNN and RNN or whatever it may be. So this is a CNN. So YOLO method will take an image and then it will classify and then figure out the box something. So if you want to look a little bit later on, so this is how. So it will keep on analyzing. So keep on analyzing and resize image, run convolution network, non-max suppression. It's like it will run. So it will keep on running here. If this is one class I identified, and here another same class. So it will say this zone I identified one class. Here also class 1. So assume that like I have 3 classes. So this is one class, this one class, this one class. I identified one class here, one class here, one class here. Like okay, I identified this whole one class. So now from where to where? First, okay, from here, class 1. Here is class 2. Here is all class 3. So then I will try to figure out and then which all places which is the class 1, I will be putting a bounding box and then I will be labeling that. Like, so resize. It's like this is how the YOLO works out actually. So if you want to know a little bit more on that, it will create a grids. So it will give 5 by 5 grids. So it will try to create 5 by 5 grid. And in this grid, what class is there? 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 So which all the grids, like so for example, I saw this get one class, for this grids one class, and this get one class, this is one class. So based on that, like it will draw the something like a final thing. So this is how the YOLO works. So I find out like I split into the grids and in which grid which classes are there, and then so S by S grids. S by S grids means like you will be saying. So it can be S can be 7, it can be 5, it can be 8, it can be anything. So I will try to grade, and this is a classification probability map. What is classification probability map? Means like what is the probability of this grid belongs to one class? What is the probability of this belongs to another class? So for example, yellow means like yellow means like highest probability, more probability. So because why I need to find out the probability? What is the, for example, this is the one grid. In that, like cat is only this portion, correct? Because cat is not covered entire grid. So from this actually, I will say, so 68% probability is cat, correct? So now, or like in this one also cycle is there, some extent cycle is there. So I will say 10% of cycle. So this grid, 10% cycle, 60% cat. So then I will be classifying this as a cat. So I need to, per grid, I need to find out the probability map. So that is what is probability maps. Like, okay, for this one, how much is, then after that, like I will be saying which is highest probability, I will associate that as that to the that grade. And then how I will be drawing the grade. So this is a grade. So like this, I will be squaring it out actually. So I have to square it out. Almost like this also, even if it is not part of this one, but like since I need to square it out, it will comes like that. And if you see this box actually, like from here to here, see, this is there, no? So this like that, and this is highest. So like this is how the bounding box will be generated. First is class probability map, bounding box plus confidence. So what is a confidence? So confidence in that bounding blocks. So together, how much we are covered. So this is the final detection. This is how the YOLO works. I'm explaining because a lot of things are there, but in a brief approach, I'm explaining how the YOLO works actually. So a lot of things I'm trying to hide because it will be too much to cover in the short period. So this is a classification probability map, and that is the reason I said it is one stage. So in a single stage, it will do. Any question so far? See, why we are discussing YOLO? Because that is what we will be building today. Fine. So second stage, the two-stage methods, like mask RNN, it is very, very popular, mask RNN. So, and fast RCN and faster RCN and mask RCN. These are the two very, very well-known methods. So how exactly this two-stage method works actually? So first is a ROI alignment. What is this meant by ROI alignment, or what is this my reason of interest? I means like interest. So in this image, I am finding out which reason is interesting to me. So I'm trying to find out reason of interest. So it's like I will keep on changing. So I will keep on figuring out this box. So this can be one box. So I'm trying to figure out which reasons are of interested. It's like I will be, this is one kind of box, this is another kind of box, this is another kind of box. So these kind of different kind of boxes are different. Like I will be creating some dummy around 1000 reasons. So different box, and each box I will try to find out and see that like which box is suitable to figure it out. So first I will be trying to find out which reason alignment. So which box, which place is my interesting to me. And then what I will be doing, then I will be running the classification. So for in this region, what class kind of object is there? So, or in this region, what class is there? That is the two. First is the first approach, like when you see this diagram. So first will be reason proposal network. So I will be trying to figure out, this is one reason interesting to me, this is second reason interesting to me, this is third reason interesting to me, or like that. How many reasons are interesting to me? And then for each one, what is that class belongs to, which class it belongs to. So this is two steps. First is the reason proposal, that is the reason of interest alignment, and figuring out which reasons are important, which position. So I'm saying that like position also, which reason or which position like is interesting to me, alignment. So this box I'm trying to slide it and say that like this is where this box and this reason I'm interested in. And then first after fixing those boxes, then I will be able to, I'm just giving the high level, but I'm not giving the, just to know that like how the process works. So two-stage process. First reason box fixing, and then within that reason, what kind of class object is there. So that is how the things happen. So that is the reason proposal network. First is the reason proposal networks. It will propose us which reasons are important. So proposes which reasons are important. And this is also convolutional network based only. So reason voice, and then for each reason, like when we identified that actually, then I will be trying to figure out which reason, which class belongs to. So in a higher level, this is how we will be doing. Any question so far? Any questions? So this, since it works in two stages, we call these kind of methods are two-stage methods. First is the reason identification, and then what kind of class is there. So these kind of methods are called two-stage approaches. So two-stage approaches. So any question here? Okay. So best methods, what all the best methods are there? What is the accuracy is there and all those things? If you see here, actually 2022 DITER is performing. So this, whenever we try to do some kind of a best methods, I said, no, we have to execute on some standard data sets. Like what are the standard data sets? So MS COCO dataset. So if you don't understand what is MS COCO dataset, it is very well known. Like, so if you see MS COCO dataset, so this is the object detection datasets actually. These are all well known. There will be organization. So object detection, segmentation, all those purpose. I know these are the object samples. So you can see. So all details about the dataset explore, like everything is there. You can download this datasets availability, everything. Like you can see that what all the other things are coming up, what all the other tasks, like so detection, key point, like dense pose. So a lot of things are there. So a lot of kind of things are there, and also that like formats. Like, so these are the you should be able to explore these kind of data sets, all these things. Okay. So now when we say MS COCO data sets, so a lot of things actually, like we'll discuss average precision. This is evaluation methods. How should I check? Accuracy is one, and other than accuracy also there are other methods are there. I said, no. So for classification, evaluation metrics will be different. Like classification, we'll be doing accuracy, confusion matrix, precision, recall, F1 score, and all those things. If it is a regression model, will be MSC, RMSC, all those things. If it is a clustering, so different kind of things. It is a segmentation, different kind of things. Things we discuss in segmentation, IOU, and all those things we discuss. Correct. So here, for object detections also there is different methods. Average precision is one. Accuracy is also there. So, but other methods also there. We'll discuss that a little bit later on. So, what is I'm trying to discuss? Like, so on this, what is called data set. So this is DETR and deform DETR. Swin transformer based. Dual swin is also transformer based. Context next is something YOLO 7 edge. It's like if you see here, actually the performances keep on increasing. So performances keep on increasing in 2023. So that YOLO 7 is performing better. So and YOLO 8 is far better than YOLO 7. So that is how we will be discussing. So vision transformer we discussed, correct? In the last class, vision transformers, using vision transformers, we discussed about how the segmentation is done. That SAM is based on the vision transformer. So vision transformer also there, like so many vision transformer based models are there. Spin is also vision transformer based. Dual spin is also vision transformer based. So this is DITER is also from transformer based. So all these things are, so like that is the reason, like if you think about core, so core, any model can be built using CNN, ANN, RNN, LST, RNN, and then autoencoder and transformer. In transformer, language transformers and vision transformers, like image transformers. If you are trying to object detections, you will be doing image transfer, vision transformers, VIT, vision transformers, correct? So all these, like if you are doing any object detection is image based, correct? So then this they will be using vision transformer based, correct? So these are all those things, different methods, and we will be studying, like we will be studying all the things in the class, but today we will be only discussing in the top-notch model. Any question? Any question? Okay. So another comparison. And what is the why I'm discussing about the comparison? You should know that like what kind of models are performing good. So from that, like what are the popular object detection algorithms are there? So these are the very popular what. So YOLO, RCNN, Mask RCN, Fast RCNN is also there. So I missed here. Fast RCN is also faster RCN is also one. Mobile net, squeeze net. So SORT is there, SST is there, DITER is there, vision transformer based. In vision transformer based, DITER is there, and all those things we discussed here, correct? So SWIN is also there. DITER, efficient net is also there, and a lot of things are there, like around 8 to 10 models are there, very popular thing. So we should be studying that. We should be building model using those techniques. Fine. So mobile net, squeeze net. See, mobile net squeeze determinant. Det means like detection. So where something like the name object detection, deter is actually detection transformer, deter. So vision transformer, swim. So short is actually simple online real-time tracking. So most of that like vehicle tracking, no, automatically you'll see short will be used. So single shot detection. So SSD, this is also very, very popular. All these are very, very well-known architectures. Like what we are trying to see here, actually, very well-known architecture, and all these are recognized. Like the top-notch research papers, which got something like a highest kind of papers, highest kind of a top-notch research papers. Like so, what you are seeing here. So around like along this, actually, like few more things which I missed here, which you should be doing is actually faster. That is missed actually. You should be looking that also. Apart from that, few more things. What I fast and faster and mask RCN, and these three are important. These four are important in this approach. And then YOLO SSD Retina Net is also important. YOLO SSD that we discussed, and apart from that, the corner and center net. So center net is important. So we'll be building, and so Cascade is also Cascade RCN is also very popular. So okay. So these are like some of the well-known kind of things. And also like if you see here, like we are discussing now. So let me show one more faster. Efficient deter is also very popular because if you see here the performance. So let me show the performance of that actually. Efficient deter, like if you see here actually the performance is here. Efficient deter is also very popular. And next deter already we discussed, correct? So VIT we already discussed, correct? So these are the one, and let me show here also like VLO convex next. This is also very important. So we will be building, either we will be building as an assignment or maybe different projects. I will be assigning one on projects of different methods, so that like we will be learning most of those advanced things. So the intention here now, so when you see that like object detection, and I have built these kind of object detection models for different applications, we'll see that like what kind of applications. So it is not that like every time we will be building for only one thing, we will be building for different applications. So one model for one applications, one model for another application, one model for another application. That is how you should say that like, okay, I have built these different things and for different applications, so that like your profile will stand out. So my intention is actually it should be stand out. So if you see that like yesterday match India and Pakistan, so if you work hard, so you can beat your opponent very fast. So it's like you will beat comprehensively. Like when you do all these different kind of models for the different applications, like 4 to 5 applications on the using object detections, then in object detection 4 to 5 with the different models, then you will stand out. Your CV will stand out compared to, and everything you should be checking into GitHub and a link to be there, and you should also describe that and create a video that, so that like your CV should stand out and you should be able to get jobs, and you can decide the salary. So if you perform very well, you can negotiate the salary. So instead of just learning little bit and just get placing, actually you put work hard actually, then substantially improve your performance and you can demand. So one example I was saying, no, there was one guy was there. So from previous salary was 8 lakhs, and since he has put a lot of effort actually last 2 years actually, 2 years experience actually, like suddenly he got another like first 12 lakhs, then 16 lakhs, then 22 lakhs, then 24 lakhs, then 32 lakhs. So he joined at 32 lakhs. So 4 times. So all this is possible, but when you try to build those kind of variations, kind of applications and very multiple models, it is not that like just I know something. So that is how you should be differentiating. Like one application would be, I said, no, this is a face recognition, person recognition. So I'm trying to face and person detection and identifying. So this is one applications. The second application would be intelligent video analytics. So it's like I'm trying, this is supply chain. So in supply chain, I'm trying to find out, this is the one application, this is one type of material, this is another type of material, this is another type of material. So we can identify what all the materials available in my stores. And why this is necessary, because this is an automation system. So it is, if you say that like you bring certain kind of product, then it will try to scan, oh, this is one kind of object, this is another kind of object. Okay, what kind of object I need to build? So it will go keep on scanning and going. Okay, it is not there. Next line, next line, next line. So it identify that, then it will go and pick up from that. So this is where the robo-based supply chain management. So it is used in supply chain management in the warehouse, actually, these kind of devices. So driverless car, no. So this is object tracking is also there. So this is how the driverless vehicle works actually. Now it is not only detecting object, but also you are tracking that object. So the plus means like sort kind of things, like object detection plus sort. So that what we discuss actually. So we will be tracking how it is moving. And if you see here, actually, this is a signal. This is one kind of object. So the this signboard is one kind of object, and vehicles are one kind of object. So it's like it'll keep on doing. So this is another one, autonomous vehicle, and this is another thing. So surgery, when you are trying to do surgery, robo-based kind of surgery, trying to find out like what is that actually object. So what need to find out like what is different kind of things. So that is another one. Defect inspection. So means like you can see that like, okay, no need to even see that like fruits are, one is identifying the fruits, which kind of fruits is there. Then advanced version of that actually, is there anything fruit is damaged or not? So we can, like, somebody is doing something that like crop or like vegetable detection or like something. No, for them it is first detecting the fruits, which kind of fruit is there, one object detection, and then whether it is damaged or not, the second detection. Then third is whether it is a what is called eatable or like just a raw, is ripe or not ripe. Ripe identifying, not ripe identifying, is any damage, means like any disease or anything is there or not, means like. So all those kind of applications, this object detections will be used. So object detection. So these are the another defect inspection. So it is not only here, even in the car defect inspection. We'll do one project on car detect, like, so something that like you see that auto or Acco video advertisement, no. So he will take a snap and then automatically insurance is settled. How is that is happened? So he takes a pic and then it will detect where is the something damage happened or not. And then first is that is update detection, and then second is actually evaluation, what kind of damage. So then the third thing is actually what is the approximate cost for that, and then automatically your claim, and if it matches, actually it will settle it. So everything is automated. Much like by doing that, actually what happens, instant insurance claim settled. So if this deep learning method is not there, then what he has to do? He has to take a photo and he has to write a write-up and he has to give that to something, and they will take it, verify it, and something like it will take a lot of time. So now automatically app geolocation, location where it is there at what time, everything will be captured from the app, and like AI based. So those kind of things are coming up. So defect inspection, it is maybe for thing, and even in the manufacturing things. So whether there's some, like when you are manufactured, whether it is manufactured defect is there or not. If a defect is, automatically it will segregate. So automatically, like instantly it will segregate. This is a defect, you should not pack. So automatically segregation of defected object, non-defected object. And even something that like in agriculture, something that like a cashew of same size or not same size, means like segregation, cashews of size or something like a thing. So this is good quality, not good quality. It's like all those places that object detection is very useful. So why we am stressing more is because like in agriculture field, in manufacturing field, in so many other applications, like in what is called supply chain, even in traffic signals and all those, like a lot of places will be, even in airport, like x-ray scanning. So like this is pedestrian tracking, like how they are traveling. And this is actually the another one. So object detection to find out the cracks in the civil structure. So drone brace, like if you slide a drone and it will try to see what is happening, the damage happening on the bridge or railway track. So the drone based, like a lot of accidents are happening on railway track. No, they are sending the drones, and drone has to see that like, so keep on flying. So saying that like a railway track is fine or not, something is happened. Like here, I'm trying to find out the bridge, and drone-based civil structure, like structure damaged or not. So here it is like identifying the cracks. So these are all the applications of object detections. These are the different kind of applications of the object detections. So in retail space, in autonomous driver, in agriculture, in security, so surveillance and security. So any violence is happening, or like people came with some kind of a objectionable object like talwar, pistol, and all those kind of things are came. Like whether the people are there or like, so automatically, like if you install the CCTV camera across things, you will able to catch actually. So vehicle detection, transportation, and even in the something trucks coming up and dumping it, actually all object detection. How many trucks came, how many water tank came, so how many water tanks gone. So all those things, like, so you can count actually, instead of like, so for example in Bangalore, like every day you will be getting one water tank to dump the water, correct? Now so it's like, so sometimes what happens, like 4 5, so unnecessary people wanted to violate, say that like instead of 4 tankers, like you'll say 8 tankers. Then if you have a camera, automatically it will count how many tankers come in, how many tankers come out. So it is very easy. So medical feature detections, like we discussed about, correct? So like that, so many places object detections is used. So why I'm stressing like you should be developing multiple things is because of this reason. So if you have to get jobs, those kind of places, then you should have done different kind of applications. That is how you should be differentiating your profile. Means like building your profile and differentiating with the other students. Any questions so far? So in detail about each one, we'll be discussing later on, because we cannot discuss all the things in one go. So these, like, so we will be discussing in detail what is F first year design, like a lot of things we'll be discussing in the, not here, but in the classes. Like, so each one, how it works, everything we'll be discussing. SPPNet, how it works, fast RCN, how it will work, all those things we will be discussing when we are trying to do. So different approaches, what is that actually, this is all research papers, and that is the reason I said no. So when you start analyzing this research paper and what is done, so after sometimes you should also able to build something and able to write research papers. So that is the next level. So first you have to build these things, then you need to start writing the research papers. And then, so that is how you should be building your profile. Any questions so far? So what all things, like if I have to summarize, like we'll take some 10 minutes break actually. So what all things we summarized, we summarize what is object detection, difference between object detection and classification and segmentation, and some kind of applications of the object detection, and how the different kind of object detection model evolution, and what is meant by single stage and two stage, and little bit like how the single stage works and how the two stage works, and applications of the object detections. Fine. So any questions so far? Okay. So after, when we come back, we will try to, and we also discussed about a lot of data sets. So what kind of data sets are there? So Microsoft Coco and where will be. So when we come back, we will see one tool called RoboFlow. It is very popular. So we'll discuss how to RoboFlow and what all things are there in RoboFlow. And we'll try to do one simple projects using RoboFlow without writing single code. And then we will discuss about how to annotate. Make sense is another tool. And then we'll start building the projects. So any questions so far? Okay. So we'll take 10 minutes break. So we'll start at 10:30. Fine. So as I said, object detection has a lot of tools. We can write without using tools also. We can also use the tools. RoboFlow is very popular. So let me show you the RoboFlow. So like one tool what we discussed in the class is from Google, TensorFlow, right? Designing a classification model, correct? So RoboFlow is the tool which will be very popular for multiple things. So what all the things we can use this is actually like one is auto detector. So if you see here actually construction, so all those kind of things. So this will be used for multiple kind of problems actually, and it is supported by a lot of players. And you see here this provides a lot of things, not only the tools to develop it actually, and also you can deploy, and also you can see notebooks also there. RoboFlow 100 data sets are there. That is what was saying, that like 100 multi-domain object detection benchmark data sets are there. So several kind of data sets are there, so which you can use it actually. So the if you want to see what all the data sets are there actually, you can see these are the data sets are there. So and so many images, like there is a kind of things are also there actually. So this is very like which data sets, like, so these are all data sets are there. So road traffic data set is there if you wanted to look into, and 2D or three-dimensional data sets also there, and people in painting is also there data sets. So like that around 100 kind of data sets are there, so which you can explore. So this is solar panel data set is there, and soccer player data set is there. If you see here, aquarium data set is there, furniture data set, street work data set is there, leaf disease. So like somebody is doing agriculture, so you can see that leaf disease data set is already there. Cotton is agriculture thing, so the data set is there. You can start exploring, like for example, is there something already data set is exist or not? If then you can explore. Cable damage data set is there. So many, like around 100 are there. Sign language, if you are building the data sets is there. Pinet is there. Like, so how should we download these data sets? Very easy. So for example, leaf disease data sets we wanted to see. If you see your leaf disease data sets, then it has it also shows like 2501 images are there. Correct. So now, apart from that, what is there actually? It shows like object detection models also there, agriculture, environment, and YOLO5 model also there, object detection and thing. So now if you want to download this data set, you can go here and see. If you see here actually, you can download the data set. So you can download these data sets are there, so you can able to download so the data sets. So fine, you can download this data set, like, so you can straight away. So while downloading this data set, so like you can check it actually, how should we download? So download with the zip or show the download code, or like, see, download code means like you can use this in a part of your Python code and you can download dynamically while writing actually. Then you can then, or else like you want to do manually, like, so download into your computers. Like, let me show that, like, continue download in your computers. And also you need to say, so you want YOLO5 or YOLO3, YOLO7. These are the well-known kind of things. No, open Vino is actually from Intel. So this is actually open Vino is from Intel. Torch, ORT, scaled, a lot of things like X, efficient deter. These are all darknet is also another, YOLO darknet is another very well-known thing. Dactron, what we say, no, efficient that. These are all the faster RCNN. So Keras based mobile net SSD to, so Jupyter notebook and Kogal notebook. So if you see here, actually, you can even go to the Collab notebook actually. So you can see this existence of this code also. So let me show that also here. So now this is the code which is available. So now about how should we use it actually? How should we? So SSD mobile net, which I'm trying to do, correct? Fast RCNN inception to ResNet. So this ResNet and all those things are basic classification layer, correct? So then this is a modified object detection, because object detection has a classification also, correct? So it will base will be classification will be used. So and then some additional box and all those things, correct? So these are modified versions. So how they have developed all those things, this code is there. You can look into that actually. So we will go through that in detail later on, but I'm just exploring what all things you do with the robo flow. So this is the one, and tutorial is also there. A lot of things you can learn from that actually. You can even understand this. You should be exploring that actually. Like the tutorial is there, so they will explain some extent. But basic things I already explained, so you can go through that. You will be able to get a little bit like more further information. And if you stuck somewhere else, like you can get back to me. We can discuss it actually. So keep exploring that. Like, so reason I'm mentioning because no, so we cannot cover entire thing, but like if you explore it, if you stuck somewhere else, if you know something is not able to understand, you get back to me so that like we can discuss further. Correct. So this is also there. So intention now I'm downloading is done. So now while downloading, you can download in what are the formats. So YOLO 8 needs a different kind of format, annotation format. YOLO 5 needs a different kind of annotation format. So Coco JSON is another kind of annotation. YOLO.NET is Pascal VC XML. So TF record is another kind of a thing. Like you can download these different formats. So these are the images you can download in a different format. So next, this is how you can download the data set. So this is a cotton data set, like so what we discussed now. So in that also like this is the person who uploaded cotton data sets. Ankit Pai has uploaded. So other person has uploaded actually. So you can also upload here. So you can also not only download it actually, you can also upload the data set. So and what is my objective is actually like whenever we are doing some projects and object detections like agriculture related things, skin related kind of things, all those things, you should take the image and create a label it actually, and then create a data set and you upload into Kaggle, also upload here also. And then because what happens actually, like when you create a data set and you upload actually, your name also will be visible. So your profile, like so you have created this data set and annotated data set and uploaded. This gives a edge over the other people, and very few people, like for example 100 people are learning AI, so only the 10% people will do this one. So you should be able to create one data set. So fine. So if you wanted to download, like you can continue downloading. So it will be start downloading. So it is downloaded. Like so it will be downloaded. Like so I have it will be downloaded. There are two I have downloaded actually. Like so now it will be in the compressed format. So let me show that also. So here I have downloaded the data set. Like so I will take only one. Okay. Now what is that actually? You can download this if you wanted to use in your things. You can compress it and you can upload to the Kaggle, and then you can build on that actually. Like so if you see here actually, the data set has training data, testing data, image and label. So it is supervised. What is that image? Image will be the something like a cartoon image. If you see here, so it's a cotton image, and label will be bounding box. So object detection, no? So it will be bounding box. So if you see here, actually, it is in form of a text. So what is that consist of text actually? This is a bounding box. Like this is x1 value, 2 value, 4 values will be there. What is that 4 value? So if you see here in this case, if I'm trying to show the image, let me write an image here. So assume that like it's a cotton image. So in the cotton image, so I say this is one value. See, this whole is an image. Assume that like this whole is an image, and this side is actually from here. From here it will start 0 to 0. So 0 and 0. This side is actually assume 1000 pixels, and this side is actually 800 pixel. Assume. Okay, means like this image is of 800 to 1000. So 800 into 1000 is a image thing. So in this one, my bounding box, like so this is actually 50 by 50, something that like 50. So this is one block point, this is second point, this is third point, this is fourth point. So this is, and then what is this actually? This 4 point, if you join, you will be getting, and here one object is there. That is what you will be seeing this text when we see. So you will be seeing this one. So this one is for one object, 1 4. This all 4 will be for one object. This all 4 will be second object. So this all 4 will be second object. This all 3. Like so, what is that you are able to see? I am trying to see 1 2 3 4 5 6 7 8. So 8 objects are there in that image. So that is labeled 8 image. So what is that image? Image was this. Where was that actually? Image. This like a name is same. So this is A100 JPG .jpg RF. No, this image, the label for that. So this is the image. In this image, I am seeing 8 objects. So 8 objects are there. So maybe cotton is an object, leaf is another kind of thing. There are 8 objects are there. So the image and label will be there. In the training data set, when you see actually image and label is there. In testing data, so image and label is there, and validation data, image and labels are there. And this data YML, so this is a YOLO format, no? So in YML format, like, so it is see here actually what all things are there. So it is saying that like what is a training image, validation image, and test image. And it is saying that like this is one class GBN, and this is second class, this is third class. So how many classes are there? 4 classes are there. Here 4 classes are there. So 4 classes are there. And this is about description about the data set. Actually this data set is where exactly all those things, version thing. So these things are this where the data set folders exist, number of classes exist, and this pattern. So you should be able to create. So how we'll create this, how to create this data set, how should we do that, we'll discuss in the next session. Actually, like once today this session will complete only, next session is like today only, like after the break. So we'll see, we'll discuss about make sense and how should we create this kind of a data set. I'm just first explaining how the data set looks like, and then we'll see how to create. So now, so this is how the data set looks like. So because why I'm discussing, because today we will be seeing that like how to create a data set also. So and so then this is how the cotton data sets will be there. So like that, if you're trying to create a data set, you should be able to create this kind of a data set. You have to zip it and you need to upload it. So when you create and upload it, actually, then you can claim that like I have created data set. Like for example, if you try to create a data set for a sugarcane disease or maybe fruits, mango or something that like you create the data set, because all this creating a new data set, it takes a lot of effort, but thing is actually it is worth, because you can claim that like I have created a data set, label the data set, upload in the Kaggle, upload in the RoboFlow. So then the possibilities like you will be, your profile will be far ahead of the other guys who are not able to do. So this is the thing wherein, and any questions about the data set, so how it looks like, and depending on that, like, so if you are trying to like, now I have downloaded for what is called YOLO. So if you are downloaded for Pascal, so the things will be different. Like let me show the one more example with the Pascal. So let me download this. Okay, so now download and see, for here also you will be able to see the things like, so video description, everything will be there. So now let me go back to the download thing. So I have downloaded, see now this is I have downloaded. Let me delete it because I have storage problem issue. Okay, now let me I will also delete this. Now we discussed about one data set. Okay. Fine, now we will be seeing that like how it looks like. Okay, so okay, now if you see here, so now the same thing, so validation train. So the data text. So what is this text consist of? We'll see. So this is some description about the data set. So it also says actually where is GitHub link is there, where is this code is there. So let us see the training data. So now if you see here actually training data is there, and image that label is XML format. If you see here actually this is the image, and the label is here only, within that only. The Pascal YOLO, the image and label will be the same thing, but in the other things, labels are separate and images are separate. So now here, if you're trying to create like, so this is how the Excel format. So Excel format, so this is how the information will be there. Here also, like if you see here actually, there is a description, lot of description is there. So this is all about, and after that, like if you see here, this is also it is like XML format, no? So it won't look nice in the notebook. Let me open in some other place. Open with notebook. So let me open at the notebook. Text editor, let me edit with this one. So this is how it looks like. So this is XML format file, correct? So this is how it looks like. And this is width and height, that image, and depth is 3. It's like 800 by 993. So the image width. So what is the image name? So image name, file name is this file. This is the file name. So it's like image file name, and path is which location it is there. And this, what is that I'm trying to get? Actually, the image size is 800 by 993, and 3 means like RGB color image, correct? So this is all about. And now what is, so this is the class name. So what is the class name? So this name of the class is given actually. And now if you see here, actually, this is the x1, y1, x2, y2, and x3, y3, x4, y5. So this is how I'm trying to define the bonding box, correct? So like that, I'm trying to define the multiple bonding boxes. So I'm trying to define. So all this is how the XML format. So this is in the XML format, not in the text format. So this is how the data set for different kind of data sets. So there are multiple ways, no? So this is one way of creating data set. Like that, if other formats you want to do, so YOLO or Coco Junction data set. So this is another kind of data format, like other formats are there. So it supports multiple ways of creating data, means like different kind of a data formats actually. So you can download any of those different data frames. So let me show one more thing. So create JSON or Coco JSON. Actually, JSON format is also very popular. See, if you see here, actually this JSON format, if you see, it will be used in efficient determinant and Dectratron 2. So if you are using Dectratron 2 model or efficient deter model, then you need a data set in the Coco JSON format. And if you want YOLO 8, then you should be YOLO format. If you want, this will be used for most of the ImageNet data sets actually. So now this will be used only for YOLO darknet or YOLO 3 kind of things. So like this will be used, this is Apple format actually. So Apple create ML, means like if you wanted to write an Apple mobile app actually, iOS app. So TF, this is another kind, TensorFlow kind of object detection. So if you are using TensorFlow, so it's like that depending on what kind of model you are trying to do, pre-trained model, we should be creating appropriate data formats actually. So we'll see that like how to do. So any question about the data set? So let me show the Coco one. So download it actually and I'll demonstrate. Any question about the data sets? Understanding these data sets?
So we can use this data set in the hackathon also.
Yeah. You can create the data set and you can upload here and you can use it, no problem. And you can use already, if it is available data set is there, you can use for hackathon. First and foremost, you need to search whether the data set is available or not, what you are looking for. If it is available, you can directly use. If it is not available, you need to create and you need to upload and then use it. So it will give a value addition. So if it is there, you will directly use. But I am also, apart from using existing one, you should try to create at least one data set. I will show you how to create data sets and all those things. That also we will discuss in the second half. Okay. So let me show this data set, how it looks like. So here also the training and testing. So now here the JPG is there. So now if you see here actually, this is how the JPG image is there. So now okay. And annotation is, all annotations are here. So categories, cotton, super category. So all annotations, everything is only one file. So in the JSON format. So if you see here actually, this ID license, this is a file name. And this is actually what is called size of that file and all those things. Like so, lot of things, everything is there in this thing. So now 226. So for 226, we mentioned, no, correct here ID. So like if you see here actually, like let me show here. So now this ID is actually like I am trying to give ID for this. So 17, like let me see 24 ID. So 24 ID is for this image. And what is the size of image? Height is 900, width is this. Okay. So now this 24 means like this image I have given and the label ID is 24. Let us go to the 24. So this is 8. This is 21. Okay, this is 24. So if you see here actually ID and image ID is 9. So now bounding box, this is one box. Okay, then segmentation, so the area. So then is crowd category. So image like so like that. This is how this is done in what is called what type of actually it is Coco JSON for format. Fine. So any question here? So this is how we will be creating or using, because you should be having some. So at least what understanding you should have that actually different data sets model need a different kind of data sets. So you should know understand that actually. So then we should be well building it actually. How to build that we'll discuss later on. So any questions so far about the data set? Okay. The next thing what we'll discuss in the robo is actually like, okay, we created a data set now. So now let us go to the data set and then we try to train this model and test this model. So I'm trying to just demonstrate the uses of the tool. So let me show here how to do that thing. Yes. Okay. So go to any one data set. No, not this one. So now we'll try to train and test or something. So let us try free. So now I am trying to show you how to build using already available data sets. So like now I'm trying to continue. So you will be doing, I will be giving some time along with me. So create account in the RoboFlow. So first you need to create an account in the RoboFlow. So and then you need to select create a new project, whatever it may be. So how to create account, you already know how to create an account. So you can go to RoboFlow and create an account. So I have created an account. So then need to do create new projects. So if you want to do along with me, please open RoboFlow and then go to the projects like and first sign up. So if you want to work with me, so first go to RoboFlow and then sign up. So sign in or sign up. So try to do that actually, and if we, and let me know when it is done. So we'll try to do together. That would be better instead of me explaining and then you forgetting it actually. So please enroll, create account in RoboFlow. So let me share here. So please enroll. So if it is done, let me know. And when we complete this, actually, you should be mentioning in your CV that like we learned in the skill set, the object detection tools used is RoboFlow. Fine. So, and also you should start writing a small description about today's workshop and upload in your LinkedIn so that like you can show that actually I have done this workshop and these are the things we are learned. So in that you mentioned that like object detection, what is object detection? We understood type of object detection, why applications of object detection and different model evaluation, all those things, and then learned about this and build this model, and whatever you have built link to that and all those things, so that like you can start promoting your profile. So when if it is done, let me know. Any question? Hello. Okay, so everybody is done. So Pratiksha, I'm assuming everybody is done. What about Janarthan and Arun Prakash and Shivani, Srishel and Ahmad? Yeah, we
Sir,
did.
I am unable to access the website from my PC.
Okay. Okay. Then what about others? Website is very easy, no? Like this is what is the issue you are getting? The URL is not right.
No, sir, not like that. I think it's my system's problem.
Okay, okay, fine. So you just copy this, paste it actually, RoboFlow. It is very easy enrolling. So just sign up it actually. I'm assuming that like you just follow. If you are not able to do it actually, you just follow how I'm trying to do. And then you try.
Okay,
It's
sir.
very, very simple thing.
Okay.
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 So I'm assuming that like everybody
Okay.
is able to do. So I will move ahead. Okay, Isha, everybody is okay. I'm assuming everybody is done. So now when we done it actually, the next is actually like this is how you will get it. So now you should be creating a project. So create new projects. So something that like you will be doing this, like create new project. So let me start with the create new project. So in this one, we should select with object detection or classification or instance segments. So we already know what is object detection, what is classification, what is instance segmentation. So we can select any of them. So classification, but in this case, this session is all about object detection. We'll and if you want more options also, the semantic segmentation is there, key point detection. These are the different things provided. But more popular is object detection, classification, instance segmentation. But now all about object detections. What we are working is in object detection. So I'm selecting object detection. Then you should be giving the project name. So something that like I'm trying to do car model detection or disease detection, dog breed detection, whatever it may be, or what is called defect detection. What all the things is depending on like I told you about like what kind of applications we would have, like depending on what kind of a data sets you have. So any of those things you can build, like predation detection or like defect inspection, any of those things. So you should please mute one. Okay. So now you should be selecting that actually, like so I have selected this, so then you should be mentioning. So maybe what kind of things I have. So for that actually, like you need to check actually what all the data sets available here, or else like you need to upload the your own data set. Okay, fine. So project name maybe I will say first object detection, or like object detection using object detection YOLO. So what you are trying to detect. So depending on the data set, what you are trying to detect. So then you need to know that like what are the data sets are available. So I'm trying to say something. So I'll say what is called animals. I'll say animals. I'm trying to detect. So create a public project, because it is a free version. You have to create a public project. Okay. So you cannot do the like what is the question? Okay, fine. So now here you can drag and drop. Like if you are trying to create it from your own data set, you can drag and drop. So here, so select files. So for example, I have downloaded some files, correct? So let me show that also. Like I have downloaded, what is this files is actually wild animals YOLO 8. So this is the file I have downloaded actually. Okay. So now you create this file. So now you can select these files. So you can drag and drop, or if you want to select a folder, like, so I'll be saying select folder. So I'll be saying select folder, and then I'll be selecting that folder. So this folder I'm trying to select it. So upload it actually. So fine. This is how, because you have already created that. So you have already created, and you will be uploading that file. So how you create a data set, that we'll discuss next one. Assume that like we have created or we have downloaded from somewhere else. Either we have downloaded from Kaggle or RoboFlow only, we downloaded. Like right now I have downloaded from RoboFlow only and I'm trying to upload there. Or if you created for your own thing, you will be upload that actually. And which format, like we discussed, no. So YOLO 8 format are different kind of formats, correct? So you here it is a YOLO 8. So what we will be discussing about YOLO 8. So now underrepresented task. No, so it is saying that like some classes are underrepresented, all those things. I'm just saying that like continue. So fine. So now automatically it will say total images are 429. Annotated image is this, not annotated image is that. So this is all try to say. So if you see here, it will show all those things. So all those files which are available. These are not annotated. So now you need to say save and continue. So save and continue. Fine. So can you able to do this much? So first thing is actually you need to download this. So first you need to download this and you need to upload this. So fine. So how to download this? That we already showed you that how to download the data set. So you should try to download the data set. And if you still forgot actually, so what I'm trying to do is actually animal data set, correct? RoboFlow animal data set. Data set. You just explore here. So pre-trained, see, animal data sets are wild animal data sets is there. So you get this data set or like a dog kind of data set, any data set. Like, so I'm trying to browse this one. You download any of those data sets. It's up to you. So you no need to download only the one which I'm trying to say. You can download any one. But download YOLO 8 only because we are trying to build YOLO 8. So when it is done, let me know. So download and upload. So now after downloading, like I'm trying to upload it. So assign image and I'm trying to continue. So fine. So after downloading, so just I'm trying to close this. Okay. So next time my image is done. So till this extent, you should be able to do upload the image and then let me know when it is done. So then I will try to do further things. So download the image and upload the image, create new project and upload the image the way I have done. And when it is done, give thumbs up, right? So step-by-step methods I mentioned in the chat window. So you do all these steps and finally you raise a thumbs up. When it is done, let me know. So then we'll continue. So go first. First is you need to go to the link. You can download any animal. It is not just only one I mentioned. And then while downloading, you select YOLO 8 format, YOLO 8, and it will be downloaded as zip format. You download as a zip format. Then you have to unzip it actually. Unzip the data set the way I have mentioned here. See, for example, here, what I'm showing is unzip format, and you just cross verify the data set is something same as the thing that we discussed how to check the thing. Then after that, what is the thing is actually log into your Logo account. So then create new project, give the name on all those details, public project, make it a public project, upload the data using select folder. So there is a images, individual images also are select folder. You just select the folder and then upload it. And then you say continue, whatever it says, save, continue, continue, save and continue, because all are labeled only. And then when it is all done, you raise thumbs up. Fine. So when it is done, let me know.
what are you detecting? I can just name it as any animals, right?
Yeah,
Animals name.
no, if depending on what data set, like you are downloaded, like this, if you downloaded the dog data set, the Stanford dog, you will mention that like dog breed object detection. Or if you
Okay.
downloaded the car data set, then you say that like car identification.
Okay.
So
So,
depending.
okay. So where should I get the data set from?
So I gave the link, no? So this link is there. You can download. See, this is browse. The link is there, no? First, you should be going
Okay.
to this.
Okay. So I'm watching the class from my phone, but that's why.
Yeah. No, usually like no workshop. Whenever I'm saying that workshop, no, you should attend using laptop, because using phone you can listen it actually, but like this is all hands-on. So along with me,
Yes,
you.
I was on my laptop, but suddenly something went wrong. That's why.
Okay, perfect. So you just observe it actually, like if you are, but doing it will be difficult in the phone. That's what like,
Yes.
so doing it like you just observe, and in your network, like who are all joining. So, yeah, so it
Okay.
will take a lot of time if downloading. That is the reason you select, like, so while selecting that thing, no, you should select the less number of images. Like everything is mentioned there. While selecting data set, like let me show here. So if you see here, actually like images are 9,900 and 9,884. So then you should not select this. So you should see that is what is your intelligent. So let me go back here. So let me click here again. Let me copy this. So when you click here, you will see animals. Like if you see here, actually, the images also there here. 1,000. You select which is the less number of images. Like 12,000 is too much. 18,000 is too much. 1,700 is still small. So just a trial purpose, no. So you see this thermal cheetah, it is 128 images. It's very easy. So actually I have downloaded this. So cheetah thing. Then the type will be cheetah identification, object detection. So you should select which is very small. That is the reason I said no, depending on your network speed. So bird is like 21,000. It is too much actually. So fish also is small. So 6,680. You say that like image. So elephant 3,000. So you select which data set. So up to you. See, for trial purpose, you do it now. But when you have the internet and high speed everything, honeybee detection. So 900. This is also small. So classification of common fish, water, pot fish, like this is also small one. You select which is very smaller one. Don't select which is very big. So it will take a lot of time to download. So if the high speed network is there, then you select the bigger one. So select the smaller one.
Okay.
Cancel that and you select the smaller one. You will be able to do it fast. This is also good. A trail camera, animal detection. So whether animal is coming or not. Simple, small one you take. Less number of images. So while downloading, select folder while uploading. So while selecting folder, you should be unzipping it actually like this. So what you will be getting in the zipped format, you should unzip, and then this folder you should be selecting.
Sir, once again, can you show me how to unzip, sir? That one?
Unzipping, like depending on like your tool. So in my case, like I have what is called Acrobat, like, so I have right clicked and then it unzipping. So depending on like WinZip is there, whatever the tool you have there in that, actually that depending. This is my Mac system. I'm see whatever it comes like this. If you go like let me download one. So let me show one simple one. Okay, so now I'm trying to download this. So I have to go here. So now I say download it actually. Okay, now I will say first I will say YOLO, then I will say zip, computer zip. So now this is how I will be getting downloaded. So now when you see the download place, okay, my thing will be downloaded. So now in my case, like open with archive. So I have this one. These are the my tools are there. Like WinZip is one more. So like here, this is how I have archived it. Like so my tools. So it is your applications. Like if you don't have unzipping tool in your computer, you cannot unzip. So here I used archive utility. So depending on that, so this is how I unzipped it. So depending on the tool what you have in your computer. Fine.
Sir, I got docs images with 50 images. But which format should I download? JSON or XML?
YOLO 8. YOLO 8.
YOLO 8. YOLO
So
8.
this
Okay.
this one, YOLO V8. V means like version 8.
Okay, got it. I got it. I got it. Okay. Downloading a zip format, right?
Yeah, zip format. So let me know when it is done.